We're talking about single responsibility principle, SRP. So SRP is one of the 5 solid principles in object-oriented design. So I'll start with this quote from T. Martins. He says that it's not enough for code to work. So take for instance, you are building a huge system, because most times the businesses and products we build are huge systems. They have different parts that comes together, and those different parts depends on each other. So in a case where you don't pay attention to the code, then you risk having a system where it is not maintainable, it is not extendable, and also not easily reusable. Alright, so what is SRP? That is single responsibility principle. Or the principle states that a component should have only one reason to change. What does that imply? It means that a component should do just one thing. It should have only one function. It should not do more than one thing. And when I refer to components, I mean classes, functions, packages, or even modules. Let's take a look at some of these systems. So, what comes to mind seeing these different tools? They are doing too many things. So this is a hammer, also a stapler. You can see the other one. It's a plier, also a hammer. So it's doing too many work. And in systems like this, if softwares are modeled in this manner, some of the problems and drawbacks you face is one, fragility. Meaning that the fragility in the sense that a change in one component or in one place affects every other component. Let's say you have class or components A, B, C, D, depending on F. So a change in F affects A to D, and it's not something we want in our system. We also have the issue of rigidity. So rigidity in the sense that this component is resistance to change. So you want to make a simple feature, but it's so difficult. It will take a lot of effort to implement that new feature. And lastly, it's more from a business side of things, technical depth. Talking about how much time and resources it will take to implement or rather improve on bad code. Because most times you see a lot of persons begin their software applications with bad code, and over time, let's say 2 to 3 years, it becomes so difficult to refactor to best practices, or even to add new features. It becomes so difficult. So how should our system look like? So we should have a hammer that can do just one thing, to hammer. Something, a cutter to cut. This I can open, I can fire, I can screw and unscrew. So in this kind of system, the component is doing just one thing. It's not trying to be a jack of all trades. Alright. So how can you see?
No.
Okay, let me see. Yes. Okay. So we have 2 screenshots. We have a class called order, and it has a method called generate order receipt. And this is another screenshot that has a class called order with generate class receipt. Can you see? You can see. Okay. No, I'm not able to see. Okay, so that's a class order, and it has a method generate order receipts. Can you see? So the other screenshot I showed earlier is a class order with receipt generator. Those are different classes. So it's easy to spot out what the issue is with the first screenshot. So in the first screenshot, we are having an order class and also a function called generate order receipt. So that class is doing 2 things. It's doing more than one thing. First, it's holding the order information, and also generating receipts. So, as per SRP, the component should do just one thing. So, a better approach would be to split that class into two. You have the order class that has information just relating to order. So, basically, this class is just storing data. That is its function. I listed out different components, classes and functions. So the next one was an example on functions, right? So a function that is doing too many things. So the best solution would be to split the function into two. Let's say the function is doing two things, split it into two. Give it a name that suits whatever it's doing. So, yeah. And there is also the case of packages. So most times you see people who do this, they have all their building language apps, you have everything in one place, right? But the best approach would be, grouping them into different packages. There's something called package by feature. So related classes, you put them in a particular package. So it makes sense you are able to access those packages or those components based on their packages. So it's easy to maintain. So this resource, and finally build an intimate familiarity with solid principles.